Now a globe Earth concept cannot exist.
Let's do it.
You guys want to do it?
Yeah, I'll do
He'll
it.
do it.
All right, perfect. Let me bring out the slides. So it's two very easy questions. They're multiple choice too.
Okay.
All right, you guys can do it together too, so it'll make it easier. All right, first one. So I have 3 box trucks here, and they're all completely sealed, and they are all on a level surface. They all also have an apple hanging from a string. The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest?
This one's at rest.
Yes.
This one's going backwards.
Okay.
This one's going forward.
Okay, how did you figure that out?
Because obviously this object's in rest. It's not moving at all.
Okay, so the object inside is not moving?
Yeah.
Sure.
This one, I'm just assuming that if you're going forward, there's going to be like an opposite force that pushes that apple backwards.
It's actually not a force, it's a fictitious force, but it's due to inertia.
Inertia, okay,
Yes.
right, yeah.
Yes, a fictitious
And then
force.
this one just opposite of that. If that one's moving forward, this one's going backwards.
Yes,
Is that
exactly.
correct?
Yeah, you got it.
Oh,
So
perfect.
again, because of inertia.
Yeah.
Perfect. All right, so the second one,
Are you sure a 5th grader would know that?
if I explained it to them and then I showed them the question again, they'll get it. It's pretty common sense, in other words. So the second one, pretty similar, but instead of an apple hanging from a string, it's a helium balloon inside of the truck. So same thing, but out of these 3, which one is at rest?
No, I feel like it's a trick.
So it's just a helium balloon.
It's just a helium balloon. Everything else is the same. Completely sealed on a level surface. One is at rest, one is accelerating forward, and one is accelerating in reverse.
So I have to find which one's at rest.
So which one's at rest first?
Okay.
A, B, or C?
I mean, I feel like the obvious answer is B, right?
Yeah, it actually is B.
Oh, okay.
Yeah, and it's for the exact same reason as the
Exactly.
first. It's because there's no change in the vector. The vector is vertical
Yeah.
still. There's no movement, right? So which one's accelerating forward?
I don't want to say C.
Okay, why do you want to say C?
Because I feel like it's opposite of what the last one was.
Yeah.
And because helium
It's
probably
less
makes
dense.
it go the other way.
Yeah, it actually is. It's the opposite effect of the other one, and then there's 2 reasons why. So the first reason is helium is less dense than air, and the second reason is a force.
Okay.
So when I applied a force in this direction, the air inside of the truck is also being forced in that direction through space. In other words, it's being pushed in that direction through space, and because air is more dense than helium, is able to push it in that same direction of the applied force.
Okay.
So you guys heard of buoyancy, right?
Yeah.
So buoyancy is an effect of a force. It follows the direction of the force.
Okay.
In other words. So, and I can demonstrate that here. Like I have a buoyant object here inside a container filled with water. Yeah. So obviously this is a buoyant object. If I apply a force in this direction, what direction do you think the buoyant object is going to go?
So if you apply the force in what direction?
This direction.
This direction?
It will go that way.
No, the
No,
We'll
wait,
go the same way. Right?
yes, the buoyant object
Oh, it's
follows
like
that
the
direction.
helium.
Yes,
Oh,
it's like the
okay,
helium.
okay.
That's a buoyant effect. It goes to the front, opposed to the back.
Okay.
Yeah,
That's
because
cool.
an apple will get left behind because the air's not dense enough to push it.
Yeah.
So the apple would just remain in its position and get left behind.
Wait.
A less dense object obviously will get pushed by the medium.
Oh, okay.
Yeah. So look, I can show that here. I recreated this experiment in a cargo van. So I want to see if you guys can tell what direction I accelerated the van, to the right or to the left. There's a helium balloon and an apple inside of a container.
So you're going that way.
Yes. So again, matter doesn't lie. You
That
know
makes
that.
sense.
Yes,
Whoa,
the helium
that's
balloon.
really cool.
Yeah, it always reacts in the direction of the force. So let me ask you this: if I have a helium balloon here on Earth and I release it, what direction does it go?
It goes up.
Yeah, because helium is buoyant, right?
Yeah.
Again, there's 2 reasons why that happens. What do you think that happens? Why does the helium go up?
Because it's less.
Dense in
Dense
air.
in the air.
Yeah, so that's the first reason. What's the second reason? What dictates the motion and the direction of the balloon?
The wind? Or the...
Yeah, well, it's a force. So again, in this scenario, it was the force of the truck pushing the air in this direction, which then pushed the helium in the same direction. What's generating the force here on Earth to push the air up to be able to push up the helium?
The moon? I don't know.
So the answer is gravity, but
Okay.
the gravity of the Earth is actually a pushing force, not a pulling force. So the Earth right now is pushing up against you and not pulling you down, and that pressure is what's creating the air pressure up and that's what pushes
Because there's like a force normal and a force
Yes,
gravity.
yes. So the normal force is the real force
Okay,
of the
okay.
Earth. So the Earth is literally pushing up on you right now, which is pushing up the Earth through space, which is then able to push up
Okay,
helium.
okay,
So
that
that's the
makes
real
sense.
force. Gravity as a pulling force, however, is just the theory. So I don't know if you guys knew, gravity as a pulling force has never been detected or measured, and that's why it's just a theory.
Okay.
So when you release an object into free fall, it's not the object doesn't go towards the ground; it's the ground that comes up to the object
Okay.
because the Earth is constantly moving up through space right now.
Okay.
So the real reason why I'm doing this is because you guys believe the Earth is a ball, right?
Yeah.
Do you guys understand that on a ball, up is relative, right? So if you're standing here, up will be this way for you, but if
Yeah.
you're standing down here, up will be like in the opposite
Yeah.
direction. So if we could prove physically that the Earth is pushing up and not pulling us down, and buoyancy shows us that, right? The Earth is literally moving up through space. How can the Earth move up in every direction at the same time on a ball if it was a ball? So if the ground was moving up, right?
Yeah.
Earth was moving. How can the Earth move up like this, like this, like this, like this at the same time, up in every direction?
There's like a force also pushing it back into the center.
So you're thinking gravity is pulling everything down,
Yeah.
and that combats the upwards push.
Yeah.
So in other words, the Earth in the globe Earth model, then the ground is not moving up then relative to us.
Well, the gravity is like warped. Like the space is warped around.
Yeah, that's Einstein's theory
Yeah.
of a pulling force. He
Yeah.
claims it's not a force though; it's a bending and warping of
Yeah,
space.
it's-
But it's just a theory that has never been physically proven in reality.
Okay.
So it's just his imagination.
Yeah. Okay.
Again, the reality is that the Earth is literally moving up through space, and it wouldn't work from a globe because in order for the Earth to move up, if it was a ball, it would have to be expanding.
Okay.
So we have to be pushing up in every direction at the same time, which means it would just expand and it'll explode. So it wouldn't work. So in order for people to believe in the ball Earth theory, they first have to believe in the theory of gravity being a pulling force. Because if we could prove that it's the other way around, that it's actually a pushing force of the Earth, then the whole globe Earth model falls apart.
Oh, interesting.
So the reality is the Earth is just a level extended plane, and it's just moving up in one direction. And that's everybody's up is the same, in other words. So yeah, so the Earth is moving up just in one direction, which is up.
How would that make the pictures that they've gotten make
Yes,
sense?
yes. So I don't know if you knew, NASA and every other space agency, they admit all the pictures they show us from outer space of
Yeah.
the Earth, they're all CGI. So they're all composites.
Really?
So a real photograph of the Earth from outer space as a ball doesn't exist.
Oh, interesting.
So they call them images, not photographs.
Oh, okay.
How would
because-
that explain the moon being like everything else being circular?
Yeah, so the sun, the moon, and the stars, they're
Yeah.
just lights in the sky
Yeah.
that, in my opinion, are just part of the Earth's system. They're not outside of in outer space, and you know what I'm saying? That's what they tell us. So nobody knows exactly what the lights in the sky are, but to try and look at the stars to prove the ground we're walking on, like the geometry, that's a red herring because the stars have nothing to do with the physical dimensions of the Earth,
Okay.
in other words.
Interesting.
Yeah. So if I was to ask you guys respectfully, why do you guys believe the Earth is a ball? What convinces you?
Well, I took an astronomy class last
Okay.
semester.
What
and,
about what convinced you, I guess, from that
Well,
class?
I remember there was like two theories like that
Yes.
people were initially thinking of, and then my professor basically just like made it. Oh, I forgot exactly what he said.
Yeah. You remember the theories? You're talking about like the theory of the Big Bang, maybe? I mean,
Well,
that's
yeah,
one
the
theory.
Big Bang, where it's like
Yeah.
everything is. It's like we're raisins in like bread, and then
Yeah.
the bread expands.
Yeah. So basically, the Big Bang theory is a creation story, right?
Yeah.
You guys obviously you guys are familiar that every religion has their own creation story. So
Yeah.
right, the Quran, it's Christian. So the globe Earth, the heliocentric model, is no different than any other religion in the sense that they give you a creation story as well. The
Yeah.
fact is, nobody knows how this place was created.
Yeah.
But it was created somehow. This is of creation. So the Big Bang, evolution, all of that are just theories to make people believe in the ball Earth.
Yeah.
Because that buys into the concept of outer space and other planets, and all that's just made
Yeah.
up. So the Earth, nobody has left the Earth system. So everything they shows about outer space is just cartoons for adults.
Really?
Yes. So NASA is just Disney for adults.
Oh,
And they admit everything they show us is CGI, but they say that they do them in Photoshop just to make them look better. That's
So
what
no
they
one
say.
landed on the moon.
No, no. So the moon is just a light. So could you stand on a rainbow? You think?
No,
Why couldn't you stand on a rainbow?
it's not dense enough.
Well, it's just light.
yeah.
Exactly, but it's not dense at all.
Yeah.
I would say because light is not. You can't stand on
Yeah.
light. So the luminaries in the sky are just light. So them claiming that we can go to these places
Yeah.
and stand on them, and that's just fairy tales. It's kind of funny in a way, but yeah,
Yeah.
It's all made up. So again, the reality is the Earth is an extended plane, and nobody knows how far it extends. So in my opinion, there is an end to the Earth. So it is being contained somehow because we have air pressure here on Earth. In order to maintain air pressure, not only do you require a force, but you require containment. So the Earth system is being contained completely. So we're
How would-
inside.
I have a question. How
Yes.
would that explain, like, how airplanes, like, you know how they'll go like up so that when the Earth is spinning, that they can just go straight down?
So I don't know.
How-
So I don't know if you guys knew. First, airplanes don't account of the Earth's spin, and they
Okay.
also don't account of the Earth's curvature.
Oh.
So they don't account for those two things.
Oh, okay.
So airplanes fly level
Yeah.
over a level surface.
Oh, wow.
So level meaning horizontal. That's what level means. No deviation in elevation.
Yeah.
You're just flying straight.
Straight.
Yes. So when airplanes are at cruising altitude, they fly straight. They don't account for Earth's curvature to go down a curve when they're going from north to the south.
Yeah.
They just go straight. Because in reality, this is what the Earth would look like if the layout of the Earth was correct, which in my opinion it's not. Here it is. So again, they show us a globe, right? And then obviously a globe has curvature, right? Like that. But in reality, if this was the true layout of the Earth, then this is what it would look like level. But in my opinion, the layout of the Earth is completely unknown. In other words, the true size and dimensions of continents are not what we're being told as
Yeah.
well. You know, this is just a projection as well.
Yeah.
But this is what it will look like. So airplanes just fly level over a level surface, you know, around the Earth like this and like this. Nobody's ever gone south, like on a globe, and then come back around north.
Yeah.
Nobody's ever done that because in reality, if you just go south, you're gonna reach the end of the Earth.
Yeah, that makes sense.
Yeah.
Wait, yeah. Oh, yeah, I thought it was like a galaxy.
We're not flat Earth, but level Earth. It's a huge difference.
Oh,
Level Earth, yeah.
Well,
Yeah.
thank you.
Yeah. So here's my information.
Okay.
Here, I'll give you my channel, and I go to USC.
Oh, nice.
Yeah, I go to UCR as well, and I have conversations with even physics professors as well.
Oh, wow.
Yeah, and they can't
Thank
prove
you.
the globe either, but
Really?
yeah, you
So
can
this
check-
goes on YouTube?
Yes.
Oh, that's
yeah, you can
smart.
check it out. Yeah.
Thank you.
I appreciate the
Thank
chat.
you so much.
Yeah, you guys take care.
Have a
All right, you too. Wait,
Are you live?
I'm actually live. Yeah.
Oh, wow.
Yeah, this one's actually live, pointing at me. This one's not.
Oh, okay.
Yeah,
Wait, what
but
is this?
so yeah, I have two very easy questions to see if people, well, the students here, can get them right.
Yeah.
So the first one here is, I have 3 box trucks, and they're completely sealed, and they're all on a level surface.
Okay.
They all have an apple hanging from a string.
Yep.
The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse.
Okay.
So out of these 3, which one is at rest?
Which one's at rest?
Yes, which one's at rest?
B?
Yes, why would you say B?
I'd say B because it's not moving. If it was accelerating forward, the inertia of A would have to go backwards, and then if it was
In
going,
reverse?
if it was going in, wait, no, if it was going forward, the acceleration or
Yeah, the
would
inertia,
have it,
yeah.
and then vice versa for C.
Yeah, you got it. Yeah, so this one's accelerating forward because of the inertia of the apple, makes it stay in its position, so
Yeah.
everything else moves forward. So you're just being left behind. Yeah, so all right, you got it, perfect. So pretty easy. So the second one, pretty similar,
Yeah.
but instead of an apple, is a helium balloon.
Okay.
So out of these 3, which one is at rest?
Okay, I would also say my intuition tells me it's B again.
Okay, yeah, and your tuition is correct. And it's for the exact same reason as the first, is because it's not moving, it's not changing the vector, it's remaining
Yeah.
vertical. So which one's accelerating forward from these 2 now?
I would say it would also be A
You think so?
for the same reason.
Okay. So it's actually C.
Wow.
Well, yeah, and there's 2 reasons why it's C. So the first reason is helium is less dense than air, right? So that's the first reason. The second reason is a force. You need a force. So when I apply a force in this direction, for example, yes, all of the air that's inside of the truck is also being pushed in that same direction through space.
see.
And because air is more dense than helium, is able to push it in that same direction
Okay.
of the applied force.
So if let's just say hypothetically,
Yes.
like if the balloon was able to stay suspended in the air, but it wasn't like
it wasn't tied to a string,
or like okay, because it's floating up because it's being like there's a tension pulling it up because it's helium. But let's
Yes.
just say that it was denser, then because
if it was denser, then it'll be an air balloon. Then it'll
go
be,
backwards.
yeah, but the string will have to be tied from the top, like the apple.
okay, so if it was like the apple, but it was
Yeah, because apple is more dense than air, so the air cannot push the apple, so the apple gets left behind.
okay.
Helium, on the other hand, is less dense than air, so the air is able to push it with it. That's what's
Okay.
happening. So the helium balloon is being pushed with the air as well,
Wow.
because the air is also being pushed.
Okay.
Yeah. So yeah, that's why it's C, and I can demonstrate those physics here.
Oh.
So again, this is a buoyant object, no different than the helium balloon. Helium is buoyant. So here I have a buoyant ball inside of water,
Yeah.
right? If I apply a force in this direction, what direction will the buoyant object go?
In this direction?
Yes.
Well, because it's buoyant, so
It-
it should go this
Yes,
way.
it'll follow the
Yeah.
same direction.
Oh,
So,
wow.
Yeah, it follows
Okay.
the same direction of the applied force of the applied pressure. That's what buoyancy is. It's a chain reaction of a force. Yeah. So here, let me show you this. I recreated this experiment in real life inside of a cargo van. So here, it's a little bit hard to see, but I'll create shade here. Can you see the helium balloon and the apple?
Yeah.
Yeah. Can you tell what direction I accelerated here? To the right or to the left?
You went to the right. Or
Yes.
my right.
Yeah, you're right. Exactly. Because again, that's the way matter reacted. So it
Okay.
shows you the direction that the air is moving because the helium balloon got pushed in that direction. So again, the air got moved in that direction, you know, and that's what shows you the chain reaction. So okay, one last question. If I have a helium balloon here on Earth and I release it, what direction does it go?
You have a helium balloon. It's
Yes.
gonna go up.
So again, helium is buoyant here on
Yeah.
Earth, exactly. So there's two reasons why a helium balloon will go up. Why do you think?
It's because the helium is less dense than
Yes.
the
air?
the air that makes up the atmosphere.
So that's the first reason. What's the second reason?
Second reason.
Yeah, there's two reasons why a helium balloon moves.
Second. I'm not sure.
It's a force. So again, in this scenario,
Oh, the buoyant force.
buoyancy is a force because if a buoyant object is moving, it's being pushed by the medium. So in this scenario, the truck generated the force to push the air in this direction, which then pushed the helium in the same direction as the applied force. Here on Earth, what's generating the force to push the air up to be able to push up a helium?
Sorry, can you repeat the question?
So here on Earth,
yeah.
what's generating the force to be able to push the air up so that then the air is able to push up a helium?
Is it the force of? It's the force of gravity pulling the air down, right, and then forcing it up.
Well, that will be the opposite effect because if the gravity is pulling the air down, then a helium balloon will get pushed in the same direction the air is
Yeah.
moving. So the reality is, it is gravity, but it's a push of the Earth. So the force of the Earth is not a pull, it's a push. So right now, the Earth is pushing up against you.
The normal force.
The normal force. That's the only real force that exists, though. So the Earth is pushing up against you right now. It's not pulling you down
Yeah,
towards
but
it.
against the balloon, it's the normal force of the air pushing it up.
Yes, so the ground is literally pushing up the air, which is then pushing up the
Pushing up
helium.
the-
That's the chain reaction of the force that we experience here.
I see.
But here's the thing. In order for that to happen, the ground, the Earth, will literally have to be moving up through space to be able to push up the air through space so that the helium balloon can move up through space as well. So everything is moving up right now and you're not being pulled down. So when you release an object into free fall, everybody believes that the object accelerates down towards the ground, but it's actually the ground that moves up to the object. So the upwards force is the only force that exists. And that's why an object appears to go down. It's because it's being left behind. Just like the apple with
Yeah.
the container. The Earth is the container and when it's moving up. So anything that's more dense than the air is just being left behind. So it's the ground that comes up to objects in free fall, not the objects that go down to the earth.
So
that-
what does that say about gravity?
Exactly. So that's the real reason why I'm doing this. So you believe the Earth is a ball, right?
Yeah.
So you understand that on a ball, up is relative, right? So if you're standing here, up for you will be this way.
Yeah.
But if you're standing down here, up for you will be this way.
Yeah.
And every direction away from the center will be up on a ball. If we could prove physically that the ground or the Earth is literally pushing up and not pulling us down, and buoyancy shows us
How are you
that,
guys?
how can the Earth move up in every direction at the same time if it was a ball to create buoyancy?
I know.
Well, I'm still under the impression that like
The air is being pulled down.
yeah, because it's like the gravitational pull of the Earth is stronger than the gravitational.
So the air is being pulled down, but then the air is also pushing helium up, even though the air is being pulled down.
Yeah, because the air is being pulled down, but it's still being blocked by the normal force of the Earth, which means that the balloon is in turn. Because you were mentioning the chain
Yeah,
reaction, it would
yeah.
in turn. It's
So I
a
don't-
normal force, but it's
Sure.
equal opposite. So it's
Sure.
like the
But-
normal force is counteracting.
Sure.
The,
Did you know though, a pulling force of gravity has actually never been detected or measured, so that's why they call it a theory. So Einstein came up with his theory of relativity, and then Newton had his theory of mass attracting mass. Both of those theories are wrong because again, a downwards force has never been measured or detected. The only force that has ever been measured is up, which is a buoyant force, which is created by the upwards push of the Earth. So a downwards pull doesn't exist. So you believe when I released this that it got pulled down, right?
Yeah.
What happens is it just got left behind due to inertia, and the table came up to the
so you're
object.
saying that we're
Constantly moving up
So-
right now. So when I release this, it's the table that came up to the object. So the object made contact with this, not this with the table.
wait. So sorry, just to be completely
Yes.
transparent, you're making a flat Earth argument right now.
So it's not a flat Earth argument.
Uh-huh.
It's actually a level Earth argument. There's a huge difference.
Okay.
So first of all, the Earth is not a ball, again, because it wouldn't work. It would just expand and explode if it was pushing up. The fact is the Earth is a level plane that's moving up in one direction.
Okay.
So everybody's standing right side up to relative to each other.
Yeah.
Everyone's facing up the same direction, and because that's the direction of the Earth's motion.
But like
wow.
what I would say to that is
Yes.
the reason why like up, like if you hold the ball on the top of the ball, up is this way,
Yeah.
right? And then if you're standing at the bottom, down, up is down, right?
Yeah.
But it's all relative because
Yes.
the center of mass of the Earth is in the center.
Yeah.
So the gravity is always pulling towards the center.
Yeah, but that's just a theory. So you're building your model based on a theory that has
Yeah.
never been proven. So if you start a model or from a false premise, then the entire model is wrong because you're starting from a false premise.
Okay,
so the
so-
whole heliocentric model starts from the premise that gravity is a pull.
Okay.
So that's why I say that's the number one proof to debunk the globe, because it's actually the other way around. In order for
Okay.
people to believe the ball Earth, they have to believe a pull.
So how would you explain things like orbiting planets and
Yeah.
satellites?
So everything about outer space, everything they're telling us about the stars and the sun and the moon, it's all just theories that are based on a theory of gravity, of orbits that are, mass attracting mass and creating. So it's all theories based on a false premise of a pull of gravity.
But when you explain practical things like
Yes.
like satellites that we've launched into space that control different things on Earth, when you look at like how we've studied the orbit of planets around the solar system and like everything else, and like how like the theory of even how the Earth is staying together as a planet because of the gravitational pull of itself.
Okay.
Like, how do you explain things like that? Are you saying, like, do you hold the stance that when it comes to like these satellites we've launched into space and anything that orbits, because I'm assuming from what you're saying that with your explanation of how things are, these like those things aren't possible because of things like are constantly getting pulled up, right? So how would you explain
Things are being pushed up, sure.
Yeah, but how would you explain like a satellite orbiting the Earth or like the International Space Station or something like that?
So a satellite in outer space has never been photographed, I guess you could say. So in other words, everything they're showing us from outer space is just a CGI. So, and they admit, they usually say that. They usually say that because they're trying to make the pictures look more, they're trying to make them look sharper. That's what they say. But they're all CGI. So there's only how high we can go. There's a limit to how high we can fly.
Yeah.
And there's a reason why. Do you understand that when a helicopter flies or an airplane flies, they have to push off of the air? Do you understand that?
Yeah.
So when a helicopter gains lift, it pushes off of the air, right?
Yeah.
So the air has to be at a certain density to be able to push off of it.
Well, the reason a helicopter flies is because the rotating blades are at an angle, and when they move, they push the air. Like when you
They're pushing off of the air.
When a rotating blade pushes this way, it's not only pushing the air back this way, it's also pushing it down because of the angle.
Sure.
So that generates lift.
Yes.
So that's what's pushing off the air, which is pushing off the ground, which allows.
But it relies on the density of the air to be at a certain density, because the higher you elevate, the less dense the air becomes.
Yeah.
It gets to a point where the helicopter cannot push off of the air anymore, and that's around 25 miles high.
Jerry, come here. Wait, I want you to hear what this guy's saying.
Want me to do the presentation to him from the start, or
no,
you just want to get into it?
He's a very smart guy. He understands
I'm not that smart, bro.
You understand the physics of this. But
Okay.
basically, like, wait, I'll just get through this really fast because I know he knows what it is. But it's just like buoyancy, right?
Buoyancy.
So if you have an apple hanging from a truck and it moves forward, the apple swings back. It's inertia, right? Same thing if it
Right
moves
here.
back, it swings forward. Right? Like this is the truck going forward, this is the truck at rest, and this is the truck swinging backwards, right?
Okay.
And then in like a similar sense, when you move it this way, it goes forward with it because the ball is more buoyant than the water. So it's the same concept, right? So basically the argument that he's making is that instead of there being a gravitational force, it's just the air going up, and in turn, instead of our planet being pulled down by gravity, our planet is what'd you say, level?
It's
Our
level,
planet is
and it's just
level
moving
and
up.
constantly
And it's not a
moving
planet;
up.
it's just a level extended plane. I would say.
So like there's just a plane that is Earth.
I wouldn't say it's a circle either. But I don't know what it looks like, but it is level.
It is level.
I don't know how it looks
So
like
flat,
as a
and
whole.
it's just constantly moving.
Yeah, it's
up.
constantly moving up.
ChatGPT now solved this?
So that's what gravity is a push of the Earth.
No,
not a pull.
basically, like the premise that I think we disagree on is that he doesn't think gravity exists and that we're just constantly moving up.
Well, it was not even my opinion. It's a fact that gravity is just a theory. It's not my opinion.
Yeah, but
That's
there's a lot.
fact.
I feel like there's a lot of things that we accept that are just a theory.
And I think that's wrong. I don't think we should accept things that are that are just theories that are not backed by physics.
No,
theories
I
are
can
okay
respect that.
if they're backed by physics. But if a theory is not backed by physics, then I would say that theory is just
But-
like the theory of Santa Claus.
But wouldn't you
That's-
say in the same way that, like, let's just say the premise is that we're constantly just moving up?
Yes.
Like that, like there. What is the reason for that as well?
It's
Like,
part of, well, whatever created this place. Again, I'm not religious myself.
Yeah.
I think all religions are there to control people. So I don't know what created this, but this is definitely a 100% a
like
creation.
this is just the way it is.
This
like,
is just a creation, and whatever created this place put it into motion, and that's
Okay.
what gravity is. It's a push of the earth.
Okay, but you can understand how I would say in the same sense, like just how you say because of, like let's just say whatever created, we can call it God, we can call it universe, whatever.
Sure.
That
That's
it moved
irrelevant.
in the
Sure.
same sense that how like the possibility of that is also the same way that there's the possibility of the force of gravity.
Sure, they just flipped the script. That's what they did.
Okay.
So they could. So the gravity, pulling force of gravity, it's a fictitious force.
There you go.
Yeah, it's a fictitious force because it's
Yeah.
based on visual perception. So visually, it does look like the object accelerates down in free fall visually because we're within the Earth reference frame. But if we were moving up with the Earth because we're attached to it, and we release an object into free fall,
Yeah.
what would you expect that object to do?
What do you mean? Like
So if we were moving up with the Earth, right?
Yeah, yeah.
If we were being pushed up right now, and I release an object into free fall, in other words, it's not being supported by the upwards push anymore. What would you expect the object to do?
it would
Be
go
left
down.
behind. Exactly.
Yeah, okay.
It would appear to go down. Exactly.
So when you say that like we're constantly moving up, does that mean in like a hypothetical sense, if we had enough fans to cover the level Earth and we just pushed all the air up, could we slow down?
No.
Why not?
So if you try to create a vacuum, for example, that's what
Yeah.
you're trying to do. Air will always rush in to fill in the void.
oh yeah, you're
Yeah.
right.
So
But
that
how
will be
would-
physically impossible. A perfect vacuum doesn't exist. So there's
No,
always gonna
no,
be
I
there's always gonna be matter.
I just think
in
that
space.
I just think that your argument against there being a force of gravity is kind of the same argument that anyone would say against like why the Earth is just constantly going up. Do you see what I'm saying?
No,
'Cause,
well,
like,
here's the thing.
so it's like you believe what you believe and I believe what I believe, but we're kind of both at some point making an assumption. You
No,
know? So
so
who are you to tell
yeah.
me that? Like I understand, like I respect that you can question the belief that there's gravity, but I don't agree with. I don't think that you have any more of a like a solidified argument with your theory than I have. With
Okay,
mine.
so real quick, a really easy experiment that anyone can do. You can do it yourself too to
Yeah.
debunk that there is no acceleration in free fall.
Mm-hmm.
So it's very easy. So everybody's smartphone,
Yeah.
even yours, everyone's smartphone has an accelerometer built in. So that's why you're able to put it in portrait and landscape, and it switches relative to the position you put the phone.
Yeah.
It's because it's detecting the vertical force of the Earth.
Yeah.
But the vertical force again is up, not down.
See that? I think that's just where we fundamentally
Yeah,
disagree.
exactly. That's where the globe Earth did the flip. But here's how we could prove that it's up and not down.
Yeah.
So the accelerometer in your phone, you could download an app. It's an accelerometer app, and it'll detect the cell phone's acceleration. In other words, so if you
Yeah.
have the cell phone at rest like this, and you accelerate this way, or up or down, that accelerometer app will detect that acceleration from being at rest to moving.
Yeah.
Because that's an acceleration from being at rest to moving.
Yeah.
So it detects the acceleration in any vector that you physically accelerated, right?
Uh-huh.
So however, when we have the phone like this at rest and I release it into free fall,
Yeah.
it detects zero acceleration. So the force goes from 1g to 0g because it's not being supported by the Earth anymore.
Wait, so are you saying that the Earth is constantly accelerating
Up.
at a rate? So like how
The
do
force
you,
is up.
How do you explain the do you believe in like the theory of the upper limit of the speed of light?
I don't believe in that theory, but I've heard of it.
Okay.
Yeah, so the speed of light, sure.
Okay.
Here's the thing, there's two possible motions of acceleration that could be at play. So the Earth could be moving infinitely in a straight line
Yeah.
at an gaining infinite speed. So that's a possibility, which
Yeah.
is no different. Globe Earth claims something similar, infinite space. And the second form of acceleration is a constant speed due to a constant change in direction. So you could have an acceleration while remaining at a constant speed if you're constantly changing your direction. So the Earth could be moving in some kind of cycle as well.
But would that not influence the, for lack of a better word, like perceived force of gravity?
Yes, that's why we have tides, in my opinion. So the tides is a horizontal movement of water, and water is level relative to the force of the Earth.
Okay,
So there is a movement to the Earth, to the oceans.
So that gets into like then again.
So that's my opinion, that the Earth is not moving in a straight line.
Okay,
but,
what about?
But it's just in my opinion.
What about like other planets or like the moon, for example.
Yeah, so the lights in the sky, for example, the stars, sun, and the moon,
Yeah.
they're just lights. So can you stand on a rainbow?
No.
Why? Why not?
Well, it's just like, it has to do with like, I forgot. It has to do with like the water vapor in the air.
Yeah, it's not a physical thing. A
Yeah.
rainbow, you can't stand on it.
But
So-
rainbows also aren't consistent. or
yeah,
constant.
so this is what the stars actually look like when you zoom into them. It looks like they're just lights that are rippling in water.
Well, the reason the lights look like this is because of like the distance of the lights and what they're made out of,
Right.
and that depends on how far they are.
Right, so these are
And
the
that's why images look
planets.
like that. Yeah.
So these are supposedly way closer than the stars. The stars are supposedly light years and light years away, and these are just like, you know, thousands, hundreds of thousands maybe
Yeah.
of miles away. Point being is with the same zoom camera, you're able to bring both into focus, telling us that they're both actually in the same position, you know, same distance from us.
Well, I don't think that's true,
In my
because
opinion.
when like the position of the sky, the stars in the sky change, and then
Sure.
predictable as well, and then that's all calculated with, you know, the orbit and
Yeah.
like where they are and how far away they are and how they move, because we can just track that over time.
Yeah,
So
so
that like contributes to the idea that that they're constantly orbiting, and then also like the sun going up and coming down is like the Earth spinning,
Sure.
because
So-
in my opinion, it's a globe.
okay.
Right.
Well, here's the thing. When it comes to the lights in the sky, it's actually when we're talking about the shape of the Earth or the geometry of the Earth,
Uh-huh.
a physical measurement of the Earth, looking at these stars in the sky tells us nothing about the geometry of the Earth. So I would say bringing the stars, the moon, and the sun as a proof to prove the globe is a red herring.
Well, how would with the level Earth explanation,
Sure.
how would you explain the movement of the stars and like you can see the position of the sun
Sure.
as well, the moon, like all of that. How would you explain that?
Well, I would say that the luminaries are rotating above the Earth. So the Earth is geocentric, not
Okay.
heliocentric.
But how would you why does that happen?
I don't know.
Because-
That's just the way it was created, but I
because-
honestly don't know.
Okay, because when
Yeah.
you think about I guess the more widely accepted view of, you know, the Earth being a globe, the planets, all
Sure.
that being the reason they're also spherical is because of gravity, you know. But that theory of gravity also contributes, and it also completely explains why, you know, the positioning of the stars, the moon, the sun, why all of that also happens. So wouldn't you say that if you can't explain the Earth consistently moving up, saying that's just how the way it is, and the same thing with all these other planets and how they rotate around what you think is the level Earth.
Okay.
Why wouldn't it make more sense for gravity to be a more reasonable explanation than what you're saying?
So again, I don't know exactly what's going on with the stars, but if again the Earth moving up, I would say the stars are kind of like a reflection. It's like a refraction, something closer to a rainbow, you know. So the projection that we see that we call stars,
Uh-huh.
I would say that it's just that. It's just a projection. It's just lights that I don't know where they're emanating from, but I think obviously the Earth, in my opinion, is a contained system. So if the whole Earth system is moving, then everything else is moving with it because it's all part of the Earth system.
So you're saying that everything is accelerating at the same rate?
Yeah, because if it's connected to the Earth,
Mm-hmm.
then the Earth is providing that upwards push. So something that's not connected to the Earth, like something in free fall, doesn't experience a force because it's no longer being sustained by the Earth.
So then like kind of the thing that you're holding on to is you think that everything is accelerating in the same direction?
Yes,
You just don't know
yes,
why.
yes. So everything's heading in the same direction. It's just the way we won't be able to walk if there was no force.
Okay. Can I just ask you a couple more questions?
Sure,
I
yeah,
have
that's
to
why
go
I'm here.
soon,
That's
but,
why I'm here. That's why I'm here.
It's just more about like there's a lot of things
Sure.
that more common perception are explained by.
Well, here's the thing. Let me just make a point before,
Yeah.
because I feel like you're just going into like perceptions and theories.
No, I'm saying that like these theories they kind of all intertwine, and they're kind of, you know, widely supported by a lot of
Sure.
things, and
What-
then there is evidence to support these things.
What if I showed you physics and math to tie into the physics that proves that there is no globe Earth?
But I would say, like, what I would say is that all of this kind of relies on the fact that you don't believe that gravity exists.
Well, well, again, it's not just my opinion. It's a fact that it's a theory. A pulling force of gravity is a theory, and the normal force of the Earth is a push. That's a fact. I'm not even making that up. You know, that's why the scientific community has to acknowledge the normal force because buoyancy is a force.
Well,
It's a
there's,
push.
There's nothing that says that both can exist.
Well, physics does. say that it can't both exist. You can only have a force moving in one direction. A force cannot move in two directions at the same time.
Yeah, I know, but it's two separate forces.
Well, apparently,
there's always an
the buoyant force is a result of gravity. But if you believe gravity is down, but buoyant goes up, that's a contradiction of the gravity causing the air to move down, but then somehow the air pushes the helium
Well,
up.
okay, the thing with the buoyant force is like, let's just say this ball is pushing up. Right?
It is pushing up. That's why the string is being stretched up.
Yeah, the string is being stretched up, but
Yeah.
that's because if you like have the free body diagram of this, the buoyant force is pushing it up and the gravity is pushing it down, but the buoyant force is stronger than the gravity, which is why it's going up.
But that doesn't make any sense because gravity is mass attracting mass, right?
Yeah.
So if this has less mass, it should get attracted even less.
What do you mean?
I mean, it should get attracted even more because
to where?
towards the
down?
Earth, yeah.
Well, the thing is the
A helium balloon shouldn't rise.
No,
if
no,
it
no.
was
The thing
truly
is,
mass
the
attracted.
gravitational pull of this water is much. It's like not. It's much less strong
Yeah.
than the gravitational pull of the Earth, which is why it's still going.
But
up.
again, you're basing that off of belief in the pulling force of gravity, which has never been proven. So again, your explanations or your way of looking at things is you're still having that belief in gravity. You know. Before you go, real quick, because
Yeah.
this is huge. Do you know the radius of the Earth that they tell us? This is how we could prove physically that there is no curvature. So the radius of the Earth is 3,959 miles.
Yep.
So based on the radius, we can calculate for the circumference. So the circumference is 24,901. That's the distance around the globe, right? The alleged globe. So using the Pythagorean theorem, so this is the formula,
Yeah.
we can calculate for how much curvature there should be every mile.
Yeah.
So every mile, that curvature has to increase. So in the first mile, there's an 8-inch drop. Second mile, 32 inches. And by the third mile, there should be 6 feet of measurable curvature. So
Yeah.
how do we measure for that curve to see if it's actually there or not, right? There's actually a very easy way. So if we went out to a giant lake that was 3 miles across,
Uh-huh.
filled with water,
Yeah.
and we build a level structure over that body of water,
Uh-huh.
the water is going to be parallel to anything horizontal above it, because once water is contained at rest,
Yeah.
the surface always collapses to form an equal surface.
But how
which is
would
level.
you measure the level structure?
Easy.
'Cause the
You know,
level structure-
you know what a plumb line is?
Yeah.
So it's like a string that's held with a weight. So
Yeah.
you get true vertical, right? So our starting reference point will be a plumb line. So we just built 90 degrees out from that plumb line. So that will be a reference, a plumb. Because even on a globe, plumb will be plumb, even on a level or a globe. And if you start building level relative to that plumb, even on a globe, if it's a globe, then the ground should start deviating
But
from
how
the
do
level.
you measure if it's level?
Well,
Are you using something like that to measure if it's level?
Not necessarily. We're keeping everything relative to this. So yeah, we could start using instrument to keep this structure 90 degrees from the starting plumb line.
Yeah, but wouldn't you just say that? Like, I feel like someone could easily make the argument that if you're building a level structure,
But that's if you're
course.
building it in sections. People are going to say that it's curving with the earth.
Yeah.
But not. But if we're
no, even if it is in one section, different materials have different levels of.
Oh yeah. So
Yeah.
you build support posts to make sure the squares stay level. So
Okay,
you
but
just-
but if you're building support posts, that is going to be level with the water, right?
No. You're put it this way. The lake could be empty. You could
Yeah.
even build a trench too. It doesn't even have to be a lake. So it could be a 3-mile long trench or lake. You could build a level structure first and then fill the water after.
Yeah.
And then if you build it correctly, in other words, 90 degrees from the starting plumb line,
Uh-huh.
when you fill the water of the trench or the lake, the water is going to even out to the level structure. But they're trying to tell us that water bends 6 feet in 3 miles and 66 feet in 10 miles. So imagine if you're at the end of a lake, and then at the other end of the lake, they're telling you that the surface of that water at the other end is 66 feet below you in 10
I
miles.
mean, has this practically been proven in
Yeah,
a scenario where they
exactly.
have built an exact?
So in China, there is a 100-mile long bridge.
Yeah.
And they took 0 account of curvature. And in 100 miles, there should be like over a mile of
The
curvature.
Great Wall of China.
Yeah.
How would they account for that level of curvature?
No, I'm talking about a bridge over a
Bridge.
body of water. So they didn't account for curvature building that bridge. So all the blueprints that we use here in construction and
Yeah.
engineers, when they build railroads, through tunnels, bridges, nobody takes account of the Earth's curvature. They actually assume that all plumb lines are parallel to each other, which wouldn't work from a globe, because on a globe, plumb lines will converge to a center. But in reality, all plumb lines are parallel.
Well,
to
I'm pretty
each
sure
other.
just like from an engineering standpoint, in terms of materials they're using and supports that they're using as well, that like even if it's a certain length, it just becomes negligible because of
A mile
force-
of curvature is
Well,
negligible?
No, it's not a mile. It's just
When
because of the force of-
100-mile long bridge?
No, it's because of the force of gravity does even out, just like it evens out the water level. It evens out the materials that are being used. As
But
well.
it evens them out curved, is what you're saying.
Yeah.
So it doesn't even them out. It
no,
curves them.
Well, it does. It curves them because
Of
but
the-
it's
because
but
of
to
a pulling
us-
force of gravity.
To us, it is perceived as flat
Right.
because
So I don't know if you've noticed though, every explanation you're giving of what I'm saying, you're just using gravity as a pulling force.
exactly. I think that's just where
That's
we
the
disagree,
Achilles
though.
heel to the globe. That's
think-
why I say that that's the number one proof to
So
debunk
I
the
would
globe.
also say that the Achilles heel to your argument is just the assumption that everything is accelerating upwards.
Well, it's not an assumption. It's based on the laws of motion and buoyancy.
I know, but
It's not a theory.
but like,
It's a law. How buoyant objects behave under certain conditions.
but it also is a theory. Just like I can drop something and say it's
no, a
gravity.
buoyant object will always react in the same direction of the applied force 100% of the time because
Yeah.
the medium that surrounds it is also moving in that direction through space. Always.
I'm surprised how many people aren't as smart.
No, believe it or not, everybody is. It's just that people doubt themselves. if
Sure.
anything.
Oh, yeah.
But everybody
the power
is.
of the mind is incredible.
Yes, it is. It is. It is.
Oh, by the way, if you ever need an orthodontist, that is for you.
Okay. Appreciate that,
Dr.
man.
Gal is the orthodontist to go to. No other orthodontist does you want to go to.
All right. Appreciate the
I
info.
have a
No worries,
I have,
man.
a meeting, so
Yes, I appreciate the chat, and here's my information.
okay, thank you.
You can check out the channel, and I go to other universities
Yeah,
as well.
yeah, yeah.
I
Okay.
appreciate the chat,
I
man.
appreciate you.
Thank you, man. Take
Have a
care.
good day.
Yeah, you too.